Hello everyone, let's discuss this problem which is based on refining of metals. So the question is, match the refining methods column 1 with the metals column 2. These are the refining methods, that is liquidation, zone refining, Mond process and Van Arkel method. And the metals are zirconium, nickel, tin and gallium. Okay. The first is liquidation. Liquidation is basically used for low melting point metal like lead and tin. In that, these metals are made to flow on a sloping surface. Okay, we have to heat these metals with impurities. So if it is tin and impurities present, if we heat it, the molten tin will flow down and will get collected in a container here, that is molten tin. Okay, by this way it will be separated from higher melting point impurities. These are impurities which will be staying on this sloping surface because it has higher melting point. It will be still in solid state. Okay, so lead and tin, basically we do liquidation. So first is going to match with C. Okay, now let's see the next one that we have, zone refining. Already we know that zone refining is based on the principle, that's the zone refining. It is based on the principle that impurities are more soluble in melt than in solid state of metal, and this is usually done for making ultra pure semiconductors devices, materials. For example, we have germanium, we have silicon, boron, gallium, indium. Okay, so produce ultra pure silicon, germanium, these semiconductor devices material basically from which the semiconductor devices are made. Okay, we do zone refining. So here zone refining will be done for what? Gallium. So second will match with D. And what is the principle? That impurities are more soluble in melt, in molten phase than in solid state, of metal. Okay. Now, the third we have Mond process. This is Mond process. Mond process basically is done for purification of nickel. Okay. In that, we heat the nickel in a stream of carbon monoxide gas. Okay, and we form NiCO4. Okay, that is nickel tetracarbonyl. Temperature is around 330 to 350 Kelvin. Okay, we are heating that. We are getting this complex NiCO4. So this nickel is impure. Okay, now it is forming NiCO4. So impurities will be left here itself. Okay, it will not be the part of this complex. And now if you subject it to even higher temperature, if you heat it for 450 or 470 in that range, and this complex decomposes, okay, and it will give you pure nickel which is free from impurity and carbon monoxide. So that's the Mond process. So it will match with the option number 2, option B. And the last one that we have is Van Arkel method. Van Arkel method is generally used for zirconium and titanium. Van Arkel, it is used for basically zirconium and titanium purification. Okay, so in that case what happens, we heat this zirconium or titanium with I2, okay, and forms metal iodide, that is ZrI4. This is more covalent, okay, because zirconium has +4 oxidation state. And then we have to decompose it on further heating using the tungsten filament, that is a tungsten filament. Okay, here the temperature of heating is far more than that is the Mond process. It is approximately 1800 Kelvin. Okay, then this complex will decompose to zirconium pure metal, okay, plus I2 vapors. So pure metal that is obtained basically gets deposited on metal filament, tungsten filament. Okay, so this is going to match with E. So if we see the correct option, that is CDBA. CDBA, and that's the first option itself. Thank you.